RealTuners Radio.
Are you interested in learning how to tune electronic fuel injection live in person with the guys from RealTuners? We have 2-day courses in dyno shops across the country. Register for all of these at RealTuners.com. Click on RealTuners Live Classes. If you'd like to bring 2 or more people, talk to us about group discounts. For more info or to make a reservation, go to RealTuners.com or message us at RealTuners LLC on Facebook. Learn how to tune your own standalone EFI systems like Holley, FuelTech, Megasquirt, Fast, and others on the chassis dyno. Includes topics such as traction control, individual cylinder tuning on a budget, and power adders. Upcoming classes with available seats are as follows. EFI Essentials in Detroit, Michigan, May 12th through 13th. And May 26th and 27th in Milwaukee, Wisconsin. Then Holley EFI Essentials at 417 Motorsports in Springfield, Missouri, June 9th and 10th. And an Essentials class covering all standalones at Nano Nitrous in Kansas City on July 21st and 22nd. These classes are designed to help you get your project running successfully in a course taught by people who've actually done this kind of stuff for a living.
What's up, everybody, and welcome to episode 42 of RealTuners Radio. Tonight, hailing from Fort Worth, Texas, we have Allison Black and Rick Tapp of Dynocom Industries. They'll be spooling us up all night on chassis dyno technology. Also, we have the usual crew of degenerates, including but not limited to Chris Delgado from ProSpeed, John Bewley, Little John's Motorsports Solutions, Tom Sewell from Fuel Injector Development, James Short, Shore Tuning, Mark Dahlquist from Throttles Performance, Bill Fowler of Bear Brakes, Doug and Andy Cook from Motion Raceworks, Scott Evans of Helix Tuning, Tom Bigu from 3V Performance and Brian Tooley Racing, Cody Bruce from Nano Nitrous, and Chad Reynolds from Bangship.com, and this guy, Rye Klemp from Bull City Speed. Then finally, a man who will take his shirt off for some Raspberry Smirnoff, Scott Clark, RealTuners.
I don't even know what that was about. Something about a shirt. What? We let Rye do these and we give him free reign. Sometimes he takes liberties.
Just getting started.
Doing good, brother. Doing fine. You are creative, and creative and weird beats nothing at all, I guess.
Something's better than nothing.
Lord. Let's see. People are already suggesting we fix that info. Smirnoff Ice. No, folks, we are not drinking Smirnoff Ice tonight. I am proudly. What am I drinking tonight? I'll just go ahead and share with everybody here who's watching the video. Check it out. Yeah, that is a Strawberryta right there. And you know what? They're pretty damn good. There's no shame in our game. Sorry, just had to share that. Anyway, so
I'm drinking NyQuil tonight.
It's NyQuil, water. What else? Anyone? Bueller?
NyQuil and Jack.
Even better.
Oh, I'm on water.
Lame.
I got water as well.
Lame. Bewley's not with us tonight. He had a hard day. I'm going home. I had a hard day, he said. I'm with him. It's okay. He usually hits it up. Mark Dahlquist is back tonight, though. Very cool. Good to have you.
I'll probably add whiskey NyQuil later.
I'm down. That sounds pretty good. The fiance got the Pizzeria stuff again, and I'm like, you know what? I'll take one of those. It's kind of all we had, but it was good. But so let's see, who do we got tonight? I got Tom Sewell. Welcome aboard, Tom. How's it going, buddy? He's on the mute button. He's like, nope, changing a diaper.
Oh, nope. Yeah, nope. I had to hit the mute button. I'm doing good. How about yourself?
Good, man. No complaints. I'm feeling pretty good. Getting ready for a class at James Short Shop here this weekend. I don't know what you're doing, but if you want to trek down to Stanford, you're welcome to sit in. It's our first HP Tuners on General Motors stuff.
Actually, there was a race this week and got canceled, so I might be down for that.
Come on down, dude. You there's room. Come on down. Just crash with us. You'll be fine. Cool. Next up.
Sounds like a good time.
Yeah. Next up. Oh, yeah, it's going to be a good time. It's going to be interesting because it's our first of this type of class, but it's actually probably going to be the best one because we're careful.
Is Bewley showing up to this one too?
I hope so. Usually he shows up on day 2 on these when we're on the dyno. So hopefully,
nice.
I'm sure he's listening. Bewley, get your butt down there this weekend to James' shop. James is literally off the show tonight because he's getting ready for it. They're cleaning up and making room because there's going to be like 23 people there. So should be pretty cool. If somebody else wants to sit in and talk to me, I think I got 2 open seats. But anyway, okay, so Evans, we got Scott Evans on tonight. Unmute yourself and say hello and let everybody know how sick you are.
I have been fighting the plague all week.
You sound horrible. Super high quality audio,
God,
but
so
you sound horrible. Ugh.
I have been fighting being able to talk. I thought about downloading like a electronic voice speak and spell type thing where I could just type and it would talk for me tonight.
We could do that. I've tried that before. It actually works
I
pretty
really
good.
thought about that.
Get the sex. There he is right there.
Oh, there it is again.
I fixed that. Evans
If
has
you are
got
playing
some.
along at home, it's time for everybody to take a drink.
Yeah, right. So here we go. You need to play your little AOL dial tone thing. All right. So next up, Rye Klemp is on board. What's up, Rye? How's it going, dude? How is your little truck project going on?
It's going good. I'm actually sitting here waiting for parts now, but I got the turbo and everything. I'm making room for the intercooler, jamming that in the front, but still driving it every day. Been focusing on the Mustang a little bit because I finally got that all sorted out. So everybody that ever gave me crap for my 4L80, y'all can suck it because it's working fine now.
Nice. Finally, Bull City transmission figured it out.
You know you just screwed yourself, right?
It's over.
I don't believe in that nonsense.
Dude, 2 weeks from now, it's done. I'm calling it right now.
I know.
Unless it sits.
At least it's a 4L80. Yeah, I mean, if it was a 60,
go faster.
It was at Shannon Taylor today. I saw Shannon Taylor make a post. So, what's the highest level 4L60 I can go with? Asking for a friend.
Yeah, I see that too.
They're up to like a level 12.
Like a level 40, 48 or something.
Yeah, good for like 109 horsepower.
It's like $12,000.
Yeah,
I'm gonna test that theory on the truck. I'm gonna leave the 4L60 in there until it grenades.
I've busted 3 of them on the first hit of the throttle.
Nice.
Yeah, I don't care what anybody says. You can't make a 4L60 live past anything reasonable. It's just the parts inside are not made to do that. No matter how much you try to beep them up, just doesn't happen.
2-3
I
shift
completely agree. I'm not even making any efforts to try and save the one in the truck. I'm gonna let it go out in a blaze of glory.
Right.
I'd be pumped if I hit a low 12 with it.
I got a buddy of mine that's got a built one, and he's right about 700 horsepower. It's held up pretty well. He beats on it pretty good, but I don't think much over that they're going to last very long.
That's what guys tell me, 600 to 700.
Time right there.
Yep.
For those of us who don't speak General Mayhem, what are the internals of a 4L60 based on?
Glass.
It's identical to a Turbo 700.
It's
but they make the
only difference in a Turbo 700 and a 4L60 is the 4L60 has an electronic throttle body,
valve body,
computer. Thank you. Electronic control valve body, and the Turbo 700 still uses the TV cable. It's manual, but other than that, the hard parts are the same.
You said a hard part.
I did.
Giggity.
It's gonna be a really mature evening tonight, folks.
Can tell. Well, Allison and Rick, let me tell you would think that they would improve upon that, but it's only going to get worse. Guaranteed.
So before we go downhill, I'd like to pimp our little activity this coming weekend.
Yes, go for it.
We'll be at the Good Guys in Del Mar, California.
And that's Bear Breaks.
That would be Bear Breaks. And so we'll have all the stuff set up down there along with our friends from Ride Tech and Goolsby and a bunch of other folks that we're all clustered around. So for those of you who like to see shiny stuff or autocross stuff or all that sort of thing.
And breaks that actually work.
Breaks that actually work. Thank you. So you're going to come by.
Hey, Bill, are you going to be in the booth out there?
I will be in the booth Friday and Saturday.
I have some buddies that are out there. That is an awesome show. If you guys are in Southern California, that's one of the better ones to go to. But I got some friends. I'm going to try and send them your way. Say what's up.
Please do. That would be awesome.
So I'm going to say Jeremy Lee just joined on, and it was his birthday yesterday, and I didn't get a chance to send him a happy birthday message. So, Jeremy, happy birthday.
Happy birthday, Jeremy, up in Mandan. Is that where he's at?
Mandan, North Dakota. It's sister city to Bismarck. So
got it.
Right in the middle of the state.
Right in the middle of nowhere. But it's a cool place. We went up there and did a class last year. Had a good time, actually. But they're way, way up there. Pretty country. Let's introduce our guests for the evening. They're probably sitting there going, why don't I get to talk? Well, first off, let's start with a guy that I've known literally longer than everybody else on this podcast. I have known this guy for, 1996. I would have met you in fall of 96. Mr. Rick Tapp. How's it going, Rick?
It's going pretty good, man.
Good. Rick is engineer at Dynocom, tech support guru. Everybody at Dynocom kind of does all things at Dynocom Industries. Met up with them 2 weeks ago at a class we taught down there. He's a master dyno operator. Seriously, I learned more at that class than most of the people going to the class would learn from me. About like operating the dyno. No, it was really cool. It was super cool. There's a lot of the mysteries of chassis dyno operation were explained to me very clearly, which we'll go over some of that stuff that we learned here later. But welcome aboard, brother. It's good to have you again.
Thanks, man.
Rick hails from he's moved all over the place, but he was in Omaha when I moved up here after in late 96. I worked. Yeah, I guess it was September 96. I moved up here and immediately met him in the car scene. Rick is the originator of the coolant pressure sensor. He's the one I learned that trick from. So that's, and Rick was a small block Ford guy who really needed that trick.
Yes. Every street race, I needed it.
Right. Time to let out. But anyway, yeah, so we go way back. And then Rick's boss is on board. Is she your boss technically?
No, I'm kind of more the boss, but we'll go with that.
Right. Miss Allison from Dynocom, welcome aboard, Allison. It's good to have you again.
What happened to ladies first?
Saving the best for last. How about that?
That's why Scott's always the first person to talk on the podcast.
You got 7 men and 1 woman in here. You think the ladies actually going to go first?
You don't know Allison, brother. She's one of the guys like nobody's business.
I do.
All right, okay. Okay. She can shit talk with the best of them. But welcome aboard. So my first time to Dynocom Industries was 2 weekends ago. I guess it'll be 3 this week. And awesome place. I had been on, of the last 12 classes that I had taught in the last year, 7 of them were on Dynocom dynos. And it was interesting to notice that Dynocom has kind of taken over the universe of chassis dynamometers. And it was kind of neat to go through that and then go visit them at their facility where they're actually manufacturing these things. And they've got, big ass Haas machines, CNC machines grinding away all day long. They were busy working on the weekend, getting dynos out the door, have a bunch of them in queue that they're building. They've got these killer huge pods with triple eddy current motors on them or generators. They can do big pro mod style horsepower. Just got so much cool stuff going on. It was neat to see made in the USA stuff getting put together here. I was super impressed, and they treated us like family. They were some of the nicest people ever. And it's funny because you talk to her on Facebook, and she probably gives a similar impression as I do. But in real life, she's a very nice person. But anyway, it was cool to meet you guys. It was cool to hang out. Welcome aboard this evening. If people have questions for you guys, just start firing away. Otherwise, we're just going to come up with our own questions about chassis dynos.
I have a question.
Bill, fire away.
What things have you seen? Some humorous, probably not, where people attempt to come in and game the dyno and maybe try to game the dyno operator to get the big number they could share with their buddies on the interwebs?
What do you mean, like manipulating the number?
Or doing stuff with the car, or
doing stuff with the car, or trying to fake you guys out about something so that they think that will inflate the numbers. We had a session a few months ago talking about how to get ready for a dyno, which I think is the more serious question. But this came up on one of the chats somewhere recently.
They want to know how to fake the dyno out.
Yeah, exactly.
Well, boy, I really don't know bringing a car in. If you could say fake it, it's more on it is more upon the dyno operator and the dyno itself. I mean, your car's going to make what it's going to make.
Let's
right?
make it
I
a
don't know how
two-part
they could-
question. Let's say what's the car going to do? I mean, I'll give you some tricks you can do. Get the oil hot first in the powertrain. That's always going to help. I mean, a tire pressure, as much pressure as it can hold, things like that. I mean, cold inlet air temps, I guess, or colder air than the dyno's measuring. I mean, I don't know. There's stuff like that.
Are we talking things that are car things we can change? Or are we talking
I think that's
things that are
phase
like,
one.
I
Talk about
changed the
car
dyno,
things. Yeah.
You know?
Phase two is what can the dyno operator do to give a fake number? You can give him beer.
Right.
Put a hair dryer on the.
Well, you could put 308
on
gears
the-
in it instead of the 411s or something.
Does that work? Not on a measure strain gauge type dyno, does it, Rick?
Oh, I mean, it can affect it. I mean, if you run in the transmission in 1-to-1, if you stick all your runs about the same duration, right, then they're all accelerating at the same rate. So really any motor, that's where all your numbers are going to be comparable. If you take the same car, yes, and just swap gears and that run is faster, it could affect, the horsepower number.
Is that because of frictional issues, inertial issues, a combination of all of them? It's a kind of a mystery, isn't it? I mean, there's a number of factors.
Well, all the stuff you mentioned, and I think just the rate that you're accelerating the motor, right? You're putting less of a load on it.
Yeah, I get that.
Changing gear in general changes the torque output. I mean, you're multiplying the output by changing it to a higher or lower gear.
Right.
That's the whole point of the gears, to multiply the output. So you're going to get a different reading if you change gears.
Yes.
Hence
So
always
if
wanting
I
to do one to
have
one
a,
gear.
Yeah, but you should be
six-speed,
calculating. You should be calculating your gear ratio every time you tune the car, so it doesn't change. I know
Absolutely, you should be.
I mean, if the dyno's set up right, minus any change in like a turbo car, how fast the boost comes in, it should read really close in each gear when you tune it.
That's where the benefit comes in from having something that has an RPM pickup versus just something with a speed pickup. Because if you're just doing something with a roller speed pickup, it doesn't know the engine RPM to give you a calculation unless you enter that data to tell it.
Well, you can.
Oh, yeah.
You can do calculate roll. You could calculate RPM from roll speed, so you can still do it in
Right.
different gears.
But with an automatic, that's going to be skewed because there's some slip, right? Whereas your RPM to tell you where it's at will be a little closer than if you're just generically doing roll speed. I roll into something with a loose ass converter and it doesn't catch up until 6,000 RPM. Then everything below 6,000 is going to be really wonky and off.
Yeah, but that's a function of the converter. That's not really the dyno's issue. That's something with the car. I mean, if you take a stick shift car, which is really kind of, you're throwing other variables in there. You take a stick shift car and you dyno it in third and fourth, it's going to be real close to the same if you set your gear ratio. I know it always has on everything I've ever owned.
So
But
back
that's
to
where
what
we're
you could
talking
do, back to what you do with the car is you could
Yeah.
give the dyno operator incorrect gear information and it could skew the numbers.
Yeah, but any dyno worth of shit, you can calculate the gear ratio backwards.
Very
If the
true.
converter's locked there, right? Not necessarily. Depends on the slip. I mean, there's a lot to it. This is all the reasons why chassis dynos will read so differently, right?
Yeah, I mean, there's no standard for them.
Yeah.
That's the issue.
And that's what Paul was telling me. Is like, listen, for engine dynos, it's easy. There's SAE standards that define how the hell to make it all to calculate the horsepower. And that's why engine dynos, it's a lot easier to be, consistent across brands.
Yes. Yeah, big stack of paperwork for that standard for engine dynos for sure.
And literally nothing to go on for chassis dynos.
Yeah, I mean, the only corrections we have, right, are weather. I mean, that's it.
I mean, hold
So
on.
for those of us,
You're saying you
There's
don't
people
calculate
that put
back
it in
to
one
a
year.
85 Yamaha motorcycle like some other company did?
Well, we can. We have a function called snapshot where it captures the roll speed, right, and determines engine RPM. So the dyno pretty much calculates it for you. And if it's a little off, you can get in and change that. So there again, that's a dyno operator thing of how do you want your numbers manipulated.
So really, it comes down to the shady dyno operators more so than
And
the
that's
dynos
the
themselves.
phase two of this question that I wanted to talk about was what can dyno operators do? So shop owners like to beef up numbers that makes them look good to their customers.
Oh, yeah.
What kind of stuff can a dyno operator do? He can get the correction factor messed up. is one of them. It's a big one.
The weather station.
Yeah.
You mess with that real easy.
Yeah, I mean, if you're using a no weather corrected number, if you look at someone's dyno sheet and there's no weather correction, then that's out of the picture, right? And then you only have to worry about the correction factor that you can change on the dyno.
So is it good for end users to take a look at what correction factor? I mean, this is what I always told people when I'm questioning an engine dyno, because I've been places where they're really playing with numbers, right? And Brad Nagel is really good at picking this stuff out, because he'll tell you, that's physically not possible to make that horsepower per cubic inch on that combo. But I always look at measured numbers and then the correction factor itself. And you can easily go look up what the correction factor should be with a quick Google search. There's a whole bunch of calculators that'll tell you that what your correction factor should be. And if you're getting if you're in Houston, Texas, and you're getting a 28% positive correction factor, then there's something to be worried about there.
Somebody stuck a hairdryer on the weather station.
Right.
Yeah.
Yeah. That happened in Louisiana on a shop that thankfully is no longer open.
I'm sure it happened more places than that.
Hey,
Scott, could we cycle back for a second for those of us that are sort of in the Stone Age and may have only ever seen, a Superflow chassis dyno or a DTS engine dyno? Would our guests from Dynocom care to share a little bit about what they produce? I'm not clear whether it's only chassis dyno or chassis dyno and engine dynos, and kind of a little bit of background on the company, where it came from, and what are the products that
Allison,
they have now.
Give them the whole spiel. When did you guys get started, and what all do you make and sell?
So DTS actually, before they got purchased by Superflow, used to, because DTS only made engine dynos and Dynocom only makes chassis dynos, we kind of partnered together up until Superflow acquired DTS. So we are strictly still to this day a manufacturer of chassis dynos, but in the chassis dyno market, we also have the US patent on hub dynos or axle dynos. So we make everything from a small 8.75 inch roller all the way up to a 48 inch roller, plus a variety of different hub dynos and different configurations. So everything from like an emissions type of dyno to OEM laboratory equipment to, speed shops, everything in between. And of course, all-wheel drive. I know most of the listeners here are probably, rear-wheel drive, big horsepower, but there's the all-wheel drive market is a really big market for us as well. So
don't forget Rye Klemp, he's here too.
Yes.
And we're remembering Rye because what? Lack of horsepower? What are we saying here?
I'm teasing. The little horsepower guys need love too. No,
I thought that was.
But yeah, take a stab at like all the guys. About Dynocom is they cover everything from industrial grade sensors and measurement to a lot of the speed shops are starting to run equipment too, and it's good stuff. You also inertia and inertia plus eddy current style power absorption unit. Maybe talk about that stuff a little bit.
Yeah, for sure. We have, Daryl DMH and Sons, his dyno that you use, that was an inertia 7500. Mm-hmm. The nice thing about our inertia dynos, of course you can add the eddy brake in the feature, is that we use like a 1.5 inch wall material. So it's a lot of inertia. And people, on the internet, they'll say, "Oh, inertia's bad. You don't want inertia." Okay, there's inertia in your drivetrain. Inertia is your friend.
Right.
You should embrace it. The old emission dynos, they used to put a large, they still do, inertia disc, because the EPA would say, for proper testing and things like a coast down test where you're trying to measure, you put the car, basically you do a negative horsepower test to calculate horsepower. That's really where you need that inertia to come in to do that negative drivetrain test.
Gotcha. The coast down test, right?
Yeah.
We just had somebody on one of the chats ask, "What's the highest horsepower 4-wheel hub dyno you guys sell?"
Did you say 4-wheel drive hub dyno or just hub dyno in general?
4-wheel drive hub dyno.
4-wheel drive hub dyno.
Do they have those?
Yeah, we do. And Nissan in Tennessee has a set. Wow. So, each pod is, a set, the lowest set is rated for 1,800 horsepower. So you can just multiply that by 2. But I don't recommend hub dynos for all-wheel drive. You really want to make sure you have a mechanical linkage for all-wheel drive. That way, there's the vehicles and the sophistication of the torque split from front to rear on some of these vehicles is like 90-10. Like we dynoed this Porsche. It's like a $1.3 million hybrid Porsche. I don't remember what it was called. It was something ridiculously expensive.
Jeez.
And the thing is like,
918.
No, it's not. I think it is. If all 4 wheels aren't turning at the exact same speed, the whole car, goes into limp mode and it freaks out. And it's like, call dealer and you're going to jail. And
You're essentially trying to simulate the rolling road.
Exactly. Yeah, you can't do that really well with, you can with 4 pods, but ideally you want it to be on a roller dyno with either a hydraulic or a belt linkage system.
I've seen a Ferrari tear out the transfer, or a Lambo tear out the transfer case because they weren't linked.
Weren't on a linked dyno.
Expensive.
Yep.
Yeah, expensive lesson.
Yep.
Yeah, we've seen that a lot, and guys still proclaim, nope, it doesn't need to be linked. Okay.
We'll happily watch you try.
Right.
Yeah, like the Tesla is another one that is impossible to dyno unless it's linked.
Interesting.
I'm
That
curious.
being a Tesla with the 2-motor Tesla as opposed to the single.
Yes.
So what do you do? Somebody else has got to be thinking this besides me. I know how you do it, but how do you calculate the engine RPM on something like that?
Yeah, I was going to ask, how do you just calculate the horsepower without having a true engine RPM? I know how you can measure torque, but you have no RPM to get the horsepower calculation.
Rick, you want to explain that drivetrain loss or?
Well, I think they're asking like if on a Tesla.
Yes.
Yeah, because it's a motor, electric.
Right. Well, my guess is you got to get an RPM pickup off the motor. I don't know that you. I haven't had the pleasure of dynoing a Tesla, so
yeah, I'm not sure how you do that.
You can. You can
output
select
with click 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 click.
Everybody take a drink again.
Current.
That's awesome. He's got something wrong. I muted him.
I'm not even mad. That sounds amazing.
That was awesome. I don't know how that happened.
I think of Back to the Future every time I hear that.
Yeah.
That's
I'm gonna hold on, take another drink of my strawberry Rita. All right. Well, so you have to take I'm guessing Rick, how would you do it if you didn't have a motor RPM? Would you do it with shaft RPM at the axle shaft, I guess? Or no, you know what I bet they do is they probably just do a capture and just pick some random RPM and just call that 3,000 RPM maybe? I don't know. How do they do that?
Well, I guess on a Tesla, right, they have, if you could capture the electric motor's RPM is what you'd need, some way just to capture that. And
there's no gearbox. So wouldn't you just,
right. So you could just go off
enough
the
wheel
shaft
speed or shaft speed is
Shaft
the
speed
same.
is it, yeah.
Right. So, if you use snapshot, you're essentially getting the same thing because you're not going to have slip, right? An electric motor hooked right to the drivetrain is it's ready to rock.
Yeah. Interesting. Well, so back to other questions. What can dyno operators do to screw with numbers to make their shop look better? Let's say I bought a Dynocom and I went through all the training, which by the way, they have just a kick-ass training facility there. We got to use that for my class and it was awesome. Best I'd ever had. But let's say I've gone to the class, everything's cool. Now I'm going back home and I want my shop to put out better power tunes and numbers than the guys down the street with the brand D, which already gives you a 15% head start. What am I doing? I guess I'm going to mess with the correction factor, or is there something I can do that still makes the correction factor like a 1.07, something believable, but gives me much bigger numbers? What do I do if I'm trying to do that, or what can you look out for if you think your guy's doing that?
Well, I guess for the end customer, it really would be hard to know because you would have to know the dyno software, right? You would have to know it inside and out and watch what they are doing and how they're setting it up.
Yeah. You would almost have to have a paper there with the correct information they should be entering to be able to know that they're not putting the right information in.
Well, it's not even that, because there's a screen where you have a power correction factor. We have it. I won't say any names, but it was first nicknamed the DJ correction factor. So you can up that number. And I mean, you can take a 300 horsepower car and just change that number, and it ends up being a 1200 horse car.
Interesting. And you can do that so that
just
you
a multiplier, right?
There's a bunch of other factors that
Yes.
might be a problem. You do that so that if you have a known horsepower car on, to kind of calibrate things. Yeah, I mean, I get that. And honestly, I'm just going to wrap this up. But I'll just say this. Amongst all of us tuners, this probably sounds like an uncomfortable or an awkward conversation, because I don't know about you guys, but I could give two shits what it's spitting out for numbers. All I care about is that I can get repeatability back to back. And I mean, we tested that a little bit at Dynocom. We definitely tested it on the first couple Dynocom. My first one was at Northern Iowa Area Community College with Garrett Jacobson. First Dynocom that I was on. And shortly after, I was on Daryl Sheltry's a couple times. And in both cases, I'm like, all right, new dyno for me. This is what we're going to do. We're going to take a car put it at low boost or low power level, something I know that's going to be pretty consistent, make 3 or 4 pulls and watch what happens. And lo and behold, it did exactly what I would expect. It'd start off at a certain number. They'd pick up just 1% or 2, 3 or 4 times. Then it would level off completely. And then, and I'm like, all right, well, the fluid temps, the powertrain's getting up to temp. So it's doing what it should do. And I was really impressed with the repeatability. Isn't that the end goal here? Isn't that what we're really looking for?
I would think so. I mean, I tell a lot of my customers, definitely don't go to one shop and get a baseline and then go to a different shop once you're done modding. That makes no sense. You're not going to know what your gains really are.
Right.
And I mean, the other big trick, obviously, is the size of the dyno. The bigger the roll, the more repeatable you can be, right? So OEMs use a 48-inch.
Traction issues?
Traction issues. On a cradle style dyno, which we didn't really talk about this, it can manipulate numbers by how hard you strap the car down. Mm-hmm. So there again, that goes to the dyno operator, but the cradle dynos have a bigger problem with that. You have to be careful how you strap them so you don't deform the tires so bad, because what are you doing when you do that?
Creating friction.
You're creating more resistance.
And you change how fast it's turning the rollers. So if
you're changing the rolling radius of the tire. Yep.
Exactly.
Got it.
Yes. Yeah. Then you're effectively too, if you're using something like Snapshot, if the tire's growing throughout the run, it's going to skew your RPM.
And tire pressure. That's a big thing on the dyno. Remember, Scott, how I had a tire pressure gauge?
Yep. You guys were all over the tire pressure. And what's the goal? What are you targeting? Is it different based on radials and slicks? Is there a preferred tire? Talk about, we have a lot of people asking about what tire should I run on the dyno? Where do you lecture people? What do you tell people when they ask that question?
Well, I guess for me, Scott, you and I had talked about this a little bit. Funny enough, slicks are harder to keep traction on a dyno because they want to be hit, right? And the lower pressure makes them a little more dangerous for coming apart when you unload them, because you've got the dyno feeding a load back into it, basically. So you have to air them up, and then you end up spinning.
Yeah, because they get greasy and they get slippery.
Yeah. So I try to tell customers, if they, are on slicks, if they can, bring a drag radial or a regular street tire. But sometimes that's not possible, right? You got guys coming in with 1,500 plus horsepower street cars. It makes it hard.
So one of the neatest things that I learned about the Dynocom dynos that hasn't been brought up yet, but Scott was talking about it, is how your rollers are round and true and balanced. Tell us a little bit about that.
Let me start off with that. First, I was asking, Delgado always told me, hey, dude, I have better luck hooking big power cars on my Dynocom, even with, kind of babyish rollers, than anything else. And I'm like, yeah, it's the usual Delgado. He's full of shit. But no, he was actually not full of shit at the time. I started noticing the same thing on the 7 or 8 dynos that we were doing for my class. Guys are bringing in some big power cars. And I know I'm lucky to hook more than 1450-ish real horsepower on a Mustang dyno, right? And similar for a dyno jet. It depends on the weight and the mass of it. Those seem to be all over the board. But I've seen 2,000 plus and high teens on Dynocom dynos, and it seemed like they were hooking. There wasn't a bunch of tire dust. It seemed like it was working. And so I asked Rick about why this is, and Rick had a really good example. Go ahead and talk about why that is, Rick.
Oh, with the customer I had to talk to during the class.
Yes.
Yeah, he had a customer had basically called me and said, "Hey, man, my roll is out of round. It's out of balance because I put a car on and it's bouncing, and then I put a truck on and it was bouncing with big mutters." And I'm like, okay, well, I would say it's in the tires because I've experienced the same thing on my dyno. I was like, but if you want to check, give me the serial number off the roll and I'll check the balance report and everything on it, which he did. I checked it and everything for our stats was, dead on passable. And I told the customer, I said, well, put a dial indicator on the roll cover, put it on the edge of the roll and spin it and tell me what the run out is. And I think I showed you the video, Scott. I mean, it was 7,000s.
Yeah.
And I said, well, that's obviously
and they keep track of that stuff
rounds
when they send the dyno out. I'm pretty sure other dyno companies aren't even checking that stuff. But he's like, no, I can check out what your run out was on your rollers. Like, wow, hadn't thought of that.
Yeah, and it makes a big difference. I mean, if you have a roll that's swinging 30, 40, 50,000 that I've seen from other dynos I've used, you think about that amount of movement in the surface of the roll, what's going to happen against the tire?
And just think about the weight because that multiplies into a force that you can actually calculate at that point.
Right. And then you start messing with strain gauges.
2,500 pounds. And it's moving 30,000. So that's a lot of weight slinging around.
Right. Even though it might be in balance, it's going to feel out of balance, right? I mean, you got that kind of weight moving up and down against the tire, then it's not going to want to stay planted. Therefore, you're going to start losing traction.
I think it was Tom that just posted in the new chat that at DEI, and Tom, correct me if I read this wrong, but between two of the DEI cars, you couldn't figure out a difference in power output between the two at the tire. And it was because the two teams had sourced the same tire from the manufacturer, but they weren't exactly the same diameter, even though they were supposed to be exactly the same tire.
Wow.
No, that is correct.
Yeah, there's Tom right there. Welcome aboard. Interesting. So they would actually run cup cars on chassis dynos as well?
Well, anyone who goes through tires on the circle track stuff, I mean, you measure that every single tire and there isn't a single one of them that's the same diameter. I mean, they're all different.
So I wanted to hear more from Tom though. On you actually put cup cars, they put them on a chassis dyno, and they do that seriously.
Yes, every engine got put on an engine dyno, qualified, but put in a car, and then the car was qualified before it got loaded in a truck and headed to the track. And I mean, every motor is plus or minus 1 or 2 horsepower. This stuff is so accurately scienced out that by the time we got them in cars, we were seeing 6 to 8 at the tire difference. And what it boiled down to was the actual tire itself. Once we eliminated the tire that each team was using to take to the chassis dyno, and they had a chassis dyno set of tires. Once we used the same tire on every car, all of a sudden that number went away.
So you're saying the cars, you put a motor in a car with a transmission, a drive shafter, and everything, and they'd be within a few horsepower of each other?
Yes.
That's pretty amazing.
Manual transmission, that helps a lot.
I mean, there's a lot of tolerances that come with like
serious consistency. That's awesome.
Yeah, well, I mean, the drive line itself, the rear end, we had our own rear end dyno. Transmissions, we had our own transmission dyno. So everything component-wise was dynoed before put together as a package. So, and this stuff is done day in and day out with the same stuff. So you keep narrowing down the packages to where they're all very, very close.
That's amazing. Well, God, I guess, did you know what brand of chassis dyno they were using for the cup car stuff?
I believe it was a Dynojet with an eddy current on it. I know it definitely had the eddy current, but I believe it was Dynojet at the time.
Interesting.
This would have been early 2004.
So maybe NASCAR really does use Pennzoil. Just kidding. Teasing.
We did,
Oh,
but it was
Lord.
specially blended.
Got it. Okay. The official oil of NASCAR.
Is that those special match set of tires that Harry was talking about in Days of Thunder that made the dyno read accurate?
Absolutely.
Hey, I'm one of the people, I don't know, I hear it thrown out there all the time. Eddy current dyno, what exactly does that mean?
Yeah, explain.
Who's explaining? Me or Allison?
Surprise us. And go.
Girl power. Maybe.
I'm just going to go back to that. I highly doubt it was a dyno jet with an eddy current back in 2000. It was most likely a dyno jet 248.
With
That
just a
was,
heavy roller.
Like, again, there's no standard gas dynos. So, but dyno jet, I'm pretty sure they bought or owned or got the rights to say they were the official dyno of NASCAR. Which again, since there's no actual official standard, that doesn't really mean anything. But from a marketing perspective, it's great. But I can tell you in 2000, there's no way that they were using eddy current brakes back in.
Yeah, that's relatively new for dyno jet in the last 5 or 6 years, right?
That may not have been a actual dyno jet eddy current, but I can guarantee you there was an eddy current on that dyno. As a matter of fact, it's still in use today. They still use that chassis dyno for anybody that wants to come by the facility and use the facility. So DEI is still open for business to other teams.
Right.
But that same dyno was there, and that same eddy current was underneath because we had a pit, and it was underneath the pit.
Got it.
That'd be
I wonder if that's a it's not a Superflow, is it?
No. Well, the software was DynoJet. That I remember. Matter of fact, I still have dyno's chassis dyno information somewhere's off it.
It'd be interesting to find out what they had. Maybe they had something customized built for them. You know what I mean? That's
very possible. Like I said, the eddy current could have been something that was added after the DynoJet was installed. I don't know. All that stuff was there when I got there in 2002. I left in 2006. So I spent 4 years on that dyno. I know it very well.
Yikes! Yeah.
Yeah, I'm sure they had to add an eddy, and to kind of keep up with the rest of the dyno manufacturers, if you ask me, because if you don't have an eddy, and going back to whoever that was question, I mean, you can't really tune on it, right? If you don't have a way to steady state, I mean, you can, but you're just doing kind of uncontrolled power sweeps, right? That are probably quicker than what the car would actually experience on the road. So how are you getting all your VE tuning done and all your loading correct?
Eric Yost just said in the Facebook chat, it was a DynoJet 248 that had to make an eddy current added, ran a BDS blower belt.
There you go. Bam.
It's a Frankenstein.
Yeah, it's a Frankenstein. Yeah, at the time, that was not something they sold yet. Interesting.
Hey, since you're talking about eddy currents, can you explain the other types of loading you guys have?
Well, did we talk about what an eddy current a motor actually is? Yeah. Some of these people probably don't even know. Let's back it up.
Go ahead, Rick. You can explain.
So there's, a couple of different styles. Ones we use is from Elsa. Basically 2 discs on the outside that are being pulled in by an electromagnet motor, right? It gives you a load. That's the only style we use. Inertia, I guess, it's not really a load. Inertia is just what the weight of the roller and what it takes to spin the whole dyno, right? So if it's just an inertia dyno, there again, it goes back to the conversation of, well, can you tune on it? There's a shop local to me that has an inertia dyno, and I have customers come to me and ask me, well, can you load my car and simulate the street? And I'm like, well, yes, I can. And they're like, oh, okay, cool, because the other shop can't.
So when you talking about the electromagnet pulls the discs in, what actually creates the load? Is it the electromagnetic field, or is it actual physical resistance?
No, it's just a field. There's no touching of parts. Well, there shouldn't be. If there is, you've got problems. So that's what's kind of nice. There's a couple bearings inside there. So realistically, an eddy brake should last a really long time. I mean, we've got some in the field that have been around 10 years and have no issues.
So it's kind of like turning a giant generator, basically. In a
so to
sense.
speak. Yeah.
It's essentially a big giant electric motor, right?
Scott,
in a way,
Scott, are you able to talk about the dyno that you used that used a pond for cooling?
Me?
Yeah.
That was an engine dyno on a giant diesel, but it wasn't actually the dyno was kind of built in because it was a generator that the diesel engine turned. It was a V20, 20 cylinders, 710 cubic inch apiece, 2-stroke diesel. And all it was an electrical generator, and they would dip these 2 big rods with a crane down into a pond, and that would increase the load on the motor and hold it at different RPMs. I mean, screaming was like 700 RPM for that thing. But anyway, now that was a little bit different. That was more of an engine dyno. But
that's pretty wild.
Yeah. I helped tune for the city of, I think it was Tampa, Florida, or St. Petersburg. St. Petersburg has a fleet of these things generating power for the city. And I was helping with a emissions project. Kind of interesting story, but we'll save that for a later date. I'll post up some videos. Cold start videos of a 20,000 foot-pound, 800 horsepower diesel engine. It was awesome.
And it was a 2-stroke diesel, you said?
2-stroke, yep.
Yeah, wow.
Really common locomotive engine.
So you have your eddy brake dyno, which puts a load on using the eddy brake. You have your inertia, which is just the weight of the rollers, and then there's a water brake also.
Yeah, there's water brake. I believe, I don't know if anybody is even still using like a hydraulic style. Allison may know. But yeah, those are the common ones. Yeah, it's water and eddy current.
I think the other hub dyno company, they use a hydraulic and theirs, right?
That's correct.
And they're not really that good.
Yeah.
Awkward pause.
Yes, I'll leave it there.
Like engine dynos use water because they're better at 0 speed and RPM. Now, don't forget, chassis dynos, you have the torque multiplier of the rear end, like we were talking about. So 1,000 foot-pounds at the crank times 410 gears, that's 4,100 foot-pounds of torque at the axle or at the wheel.
Interesting. Okay.
Engine dynos don't have that multiplication factor.
So that's why you don't see a lot of water brake deals on chassis dynos, mainly because the water brake works at the 6, 8, 9,000 RPM, but the shaft speed on the wheels is much slower and much higher torque. So it takes a completely different setup to be able to absorb that power or torque.
Plus, they take up a lot of room.
Well, yeah, I mean, that'd be probably the biggest thing, Scott, is a water brake engine dyno. You got to have, a large cooling tank and the pumps to go through all that. That's a lot of room and a lot of stuff for, some of these small shops that can have a chassis dyno, but they can't have that whole setup.
The cool part about an eddy brake is that if you build it with big enough coils, the more electricity you can put into it, the harder it can hold something, which means you can hold some really, really large loads if you really need to. And you can do it like the engine dyno. The water brake will hold a lot of load, but it takes a lot of space to do that water brake. Whereas the eddy current takes up a fraction of the space and can hold more, I would say, at that point, once we're considering the torque multiplier of your transmission and your rear end. So you can just turn up the juice to those things, put big coils on them, and you can really, really hold a lot of force.
Yeah, they work very well, as shown in the tripod series that Dynocom has.
That's your guys' new hub dyno, right? This holds something crazy like 9,000 horsepower.
Tripods. Yep. These things are bad tripods. Sorry.
No. I mean, they're a work of art. I mean, they are the most powerful hub dynos you can buy. We rate the one model up to 10,000 horsepower. They use a transmission. We'll build it with 2 eddies or 3 eddies. The 2 eddy model, which I believe you saw, Scott, it still has a inertia drum up top.
Which is interesting. That means the computer's got to do math for both the inertia and the torque. And you guys actually have load cell style strain gauges. First time I'd seen one of these, Eric Yost showed it to me.
Scott?
it's the same thing that the load cells like the NASCAR guys use. It's not quite the same wheat bridge resistor thing that's on some of the engine dynos that's cheaper. It's actually a pretty neat little deal. It doesn't move very much.
Yeah, 6,000s either way.
Yikes. So anyway, big hub dynos, very cool stuff.
I've replaced a few of those load cells for people.
Say that again, Evans.
They're fun to. I said I've changed out a few of those for people when they've failed over time, or they got water in the pit and didn't realize it pump wasn't on or something. They're fun to change out. They're not cheap.
Yeah. Yeah, luckily you don't see a lot of failures with those. I mean, it's they're pretty rock solid as long as you don't stick a car on the dyno that is way more power, than what the dyno's rated at. They don't usually have too many issues.
So let me ask
you guys
this.
are all just really.
Sorry, I got to ask this question. I'm surprised Dahlquist hasn't asked it yet. Why have you thought about getting into engine dynos at all? Let Allison answer that one. She's been there
Scott,
longer.
I'll make it for you. Yeah, for you, Scott, I'll make anything you want. You know that.
Brad was asking me today why we would really love it if they came up with an engine dyno, because that let's talk offline about what's going on in that marketplace. But yeah, an engine dyno would be a cool thing.
Scott, can you hear me?
I'm sorry, ask that again.
This is Dan. I had a question.
Oh, Dan Parker, welcome aboard. Hey, so anybody else having trouble with the chat? The blind guy figured it out. Just saying. Welcome aboard, Dan Parker.
That's bad.
No, go ahead, man.
That's
you
bad
had a question.
The blind guy. Yeah. When they were talking about eddy current for the dynos, could they explain how many amp draw, like say a 2,500 horsepower dyno would take, and the is it all 3-phase, and how many amps? That'd be something the shop would consider before purchasing, to know what kind of electrical resources they have to have in their own building too.
Right. I mean, before the tripods, they're all single phase 220, either 30 or 40 amp supply. So not much.
Okay,
really.
That's very reasonable.
Yeah. The tripods, we will do a 3-phase version, which will help with amp draw. It doesn't require as much to run them. But I think the 3-phase is limited to the triple eddy versions, if I'm not mistaken.
So 3-phase, you're running that as a step down from the 460 at the panel.
We have a transformer built into it. I mean, it really depends on the shop. We go over that with who's interested, based on what they need. You know what I mean? And we discuss, okay, this is what you have to do for power.
So if a shop already has, say, 208 3-phase in there and they're ready to go because they have some other machines that require that, they need to do anything special or different?
No, not with the tripods. I mean, that's obviously way too much for any of the other dynos. The tripods are the only ones that we do and can build them in a 3-phase option.
These tripods sound gangster. What do they cost?
Allison?
Is Chris Delgado listening? Is Chris Delgado on the line?
Nah, he's not on right now.
Yeah, he left. I saw him.
Okay. Yeah, exactly. They retail for depending on the configuration between 80 and 110,000.
It's actually not as bad as I would have expected. I know guys that are paid more for competitors.
Really
I was
bad.
expecting almost twice that.
Yeah, I find that to be a
basement tonight.
I might have missed this earlier. Do you folks make, Tom referred to transmission dynos and rear end dynos and brake dynos? I don't know. Do you make any of those other allied type products for doing that kind of testing?
We don't. The only one I know that makes a transmission dyno is Superflow.
Yeah, I think
a lot of the teams build their own test equipment too.
Yeah, I don't know if they're still around
Yeah, I
or
don't know
who they got them from. At Axie did a lot of transmission dyno.
Our stuff was all built in house.
There you go.
in-house.
Okay. What else we got, guys? Asking
But I
here?
mean, you can buy a 24-inch roller with an eddy current brake for $30,000, turnkey done. So it's hard to build a data acquisition system for. If you're going to build a data acquisition system with all the sensors, it'll probably cost you at least 10.
That's pretty cheap, actually. Plus, you can get those things financed, right?
We don't say cheap; we say less expensive.
I just spent $30,000 for a tool like that. It's fairly cheap.
Dealing with
That's
a
very
marketing
reasonable.
expert,
Yes.
you got to use your terminology carefully, Tom.
Yeah.
Malcolm Stridham has an interesting question. He says, can you elaborate on the hub dyno's foot-pound torque rating? Your Dynocom X hubs are rated at 2,400 foot-pounds. Do you have to divide by the rear end gears, say 3.55, and the rating is only 676 foot-pounds at the engine?
No, the foot-pounds of torque is based on the eddy current brake capacity of the holding capacity. So every brake has its own chart showing its maximum capacity for holding power, and then where it drops off, because eddy currents they can only dissipate so much heat, and then they fall
It's
off.
rated for tire rating 2,400 foot-pounds is what he's trying to figure out. Is it when you say it's 2,400 foot-pounds, he's trying to figure out if you have to divide by something based on the gearing and stuff. And
He's asking, is that 2,400 foot-pounds at the tire?
Yes.
Really?
yeah,
At the axle.
At the axle, correct.
Which would only be 600 foot-pounds at the engine.
No.
if you had a 4
She's talking after you're all done, it'll hold that at the tire, correct?
That's correct.
But earlier
if
we said if the
So
engine,
a
if
pro
the
mod,
engine's-
basically, or almost a pro mod with an auto trans, or
Yeah.
a slow pro mod. You know.
Yeah, you guys are way overthinking this. If they say 2,400 foot-pounds, it's 2,400
To the-
foot-pounds to the tire or to the
Okay, but earlier it was said 600 foot-pounds at the crankshaft times 4 is 2,400 foot-pounds at the tire.
Yeah, of course, but that's what
That's
the
before
dyno
the
does for you.
calculations run with engine
Yeah,
RPM.
it calculates all that for you. So that's why if you have a good dyno and it's set up right, if you dyno in each gear, it's the same horsepower reading, even though it's technically not the same horsepower at the rear wheels.
Okay, but you didn't understand the question.
Well, I think what the guy was asking is, say if he has a 600 foot-pound motor and he's in 1-to-1, if he has, what do we say, 355 gears?
We'll say 4, just say 4-to-1 so that
Yep.
the math is easy.
Okay, so a 410 gear would stick him at 2,460 foot-pounds of torque at the axles. So, they would hold it. I don't know if they'd steady state it, you know what I mean? But it's going to obviously give them a ton of resistance.
I think the problem here is coming in that he's looking at it like, oh, I'm only making 676 foot-pounds of torque, and that comes out to 2,400 at the wheel. No, it doesn't. Your 600 foot-pounds of torque does not come out to 2,400 foot-pounds at the rear with that gearing. It doesn't quite work directly like that. If you're making 600 at the engine, you're making less at the rear wheel.
That's not what was stated
Yeah,
earlier, though.
I think he's right though. It was quoted earlier, and I think that's where the confusion comes in. So probably just ought to start all over and re-explain how it's all rated and how you come to that answer.
Hang on, guys. Let me get my abacus so I can figure this out.
Well, I think what they're saying is, is that 2,400 pound number? Does that mean he's limited to a 600 horsepower engine or 600 foot-pound engine at the flywheel? And the answer is no, right?
Obviously not. Yeah,
no, clearly not. So no, because I've been way over that number on the even their smallest dynos, over the 600 number at the flywheel. So they're talking about real torque, but that number that it spits out has gone through all their equations and all their math and everything. That's trying to give you an idea a little more. That is trying to compensate for, or I guess back compensate for the gearing, right?
Oh, I see what you're saying. So, because you do have to talk two different torques. You got to talk the actual torque number you're going to give the customer,
Right.
but then there's a torque number that the dyno sees.
Right. Yeah, the 2,400 foot-pounds of torque is the rating based on the output back calculated through all your gearing for a typical vehicle. They're not saying it's specific to a 355 or specific for 410. It's probably an approximation to fit a range of all gearings and all transmissions to get you close, so that your engine horsepower, engine torque,
this call
is
needs
probably
Paul.
well.
Sorry, Paul would explain
Right.
this to us so clearly. I'm guessing it's back calculating. So that you got your strain gauge is going to measure the gear ratio, the torque, right? And it's going to come up with less horsepower, but you're measuring the engine RPM. So it's back calculating for that based on engine RPM, and it's basically backing out the gear ratio. It has to physically hold that higher torque, but the number it's going to report is absent that gear ratio. What it's supposed to do, because they're supposed to measure the same power with the different gear ratios.
Yeah, the actual motor output doesn't change based on the gear ratio. It's the tire output that changes, and the dyno makes it so you're actually getting what the engine's making.
Boom.
Correct. Which is why there's no confusion on the interwebs or anywhere else about how all this stuff works.
Oh, it's totally confusing, man. And think about this. It's not really what the engine's doing, because I know, and from doing this with Bill and about 10 other friends for the 2 years I was out there in charge of a Mustang dyno, and right down the street from a DTS, we would take engines off of Urbancic Brothers engine dyno. And if I knew roughly what transmission and converter config, if it was for a street strip drag weak type car, I could tell you that they're always going to show 34 to 37% loss, at least in the 600 wheel to 1200 wheel, the power numbers that we saw on cars like this. They were all losing a similar percent. So it wasn't really reporting what was at the engine. It was reporting what was happening at the wheels, but it's backing out that RPM, the reduction in the torque multiplier in the rear end gear ratio.
I have a feeling we just confused the hell out of everybody.
Yeah, I probably did. Sorry. I'm just saying it's not well, put it this way. You have a 410 gears and a 600 horsepower engine that's 600 foot-pounds of torque at 5,200 RPM. It doesn't show 2,400 foot-pounds of torque on a chassis dyno. It shows you 600 foot-pounds minus about 30-some% through an automatic transmission typically, or maybe 20% through a manual. So that's the end result. The why, I'm not entirely sure of. It's interesting. But I'll tell you why. This really explains why it's hard to get consistent numbers out of a chassis dyno. Maybe it's consistent numbers for a given setting or given car and project and evening or whatever. But dyno to dyno, good luck. Going across the street, different guys, different operators, different setups, whatever. And that's it takes you right back to Rick's original point. Start with the same dyno and try to make everything the same and as consistent as possible every time you go back in for a baseline and then a comparison after updates or upgrades. I'm
going to kind of switch gears here. You guys, is there anything that you recommend when somebody goes to get their car tuned somewhere that, hey, they have this dyno set up wrong, they don't have proper airflow, this isn't what you want to see when you get your car tuned? Anything you can recommend like that?
Airflow is a big one. What happens if you're in a shop running your car and you're getting a headache? The engine is breathing that same air, right? So you want the engine breathing clean air, just like you want to be breathing clean air. So that's important. The other airflow aspect is, can they keep your car cool enough? You don't want to have the thing going beyond a temperature that you would never see on the street when trying to make a power pole.
And the other thing I would say too is location of the O2 sensor for air, fuel, or lambda tailpipe versus, don't be lazy, weld a bung in tailpipe reading versus location of where you're going to put your O2 sensor. So that'll make a big difference.
Yeah. You might ask them
if they have the right pipe to put in your tailpipe to get it to basically extend out. So one of the biggest problems with the tailpipe is you get a free air, an interference of it, basically a contamination from the. Couldn't come up with a word there. And you can circumvent that by having a pipe of your own, if you don't have a second bung, a pipe of your own that you could stick in that matches the same diameter, that slips onto the pipe, that has a good couple inches of overlap, and then sticks out another 18 to 24 inches beyond that. And that will help drastically with making sure that you're at least not getting outside contamination if you can't put a second bung somewhere.
Yeah, I mean, ideally in a bung, ahead of a cat is the best place, especially if you're trying to do idle tuning, stuff like that. That's what you want to have.
What's the recommended process when you're dealing with, sort of the typical open header? You put the word race car in quotes these days. Never mind, NA, but also, dump. You go to the dump tube. You guys do turbos all the time, more about than I will. But are there sets of recommendations that when you're talking to prospective operators or existing operators that have a set of standards for them to follow?
Probably not a set of standards, just again, using some kind of standpipe, right? I mean, if it's a really short up pipe, like I think we ran into this, didn't we, Scott? Where the down pipe was so short, we weren't sure if the O2 was getting a good reading at lower RPMs.
I tuned that all the time. We run into that all the time. Yep, especially big cams, short down pipe. Hold on, I'm going to mute whoever's making all that noise. I apologize about that.
In my car, I got a 5-inch downpipe kicking out the side. It's about 20 inches long total, and I get weird readings at idle.
Yep. You're going to get lean. That's why I always tell people don't use the AFR, don't use the wideband to tune anything but half throttle or under load. You'll know when you're starting to get a good signal. But one of the biggest mistakes noob tuners make is trying to tune. Big cam engines are the same way. They'll actually revert. They'll cause reversion. They'll bring oxygen all the way up 8 feet of tailpipe or of exhaust pipe. So I just tell people don't start using the wideband. Don't trust the wideband until you start getting a load on the engine. You'll know when it comes around.
See, I'm a little different. I like to have a bung with an O2 on every car, and then I'll use the dyno wideband as a backup if I need something to look back to as a standard, and that's about it. At least that's how I do it.
Yeah, I've done that a lot myself. Use a bung on the car, and then have the old booty sniffer, giggity.
Lovely.
Stick my O2 sensor in your bung.
Yeah.
Bung hole.
We are all just grown children.
RealTuners does not endorse. Good Lord, I don't even know where to go with that one.
Thanks.
I had to get that thrown in there at least at one point.
Yeah, I don't. You're in good company, sir. I am a giant man child.
It's nothing but fun. I mean, you have to keep everybody entertained, right? We got to make people laugh. So they're just going to leave.
I would think we're just bumbling through it, but our listener count would imply otherwise. There's a huge number of listeners listening tonight. Thanks all you guys for tuning in and putting up with our crap. Bewley's not on here, so we're probably extra clunky. He always makes things smooth out. It's kind of funny.
I think they're probably waiting for us to talk about broken stuff.
Yeah.
Oh,
yay, broken
failures.
Stuff. Yeah, before we go to epic failures, can I just ask one other question? As a consumer, you're going to go interview a dyno shop. Now, obviously, there's one particular kind of dyno we would love them all to have, but they may or may not have yours. So what are things that the typical person going in to use a dyno shop for the first time should be looking for, asking of the operator of the shop to make sure that they're going to get a fair deal and proper work done, or at least calibration?
When they're selecting a shop, what kind of stuff do you look for?
Well, I don't know, because I am the shop, so I don't shop. I mean, I guess for the consumer, look at what they've done. I guess. I mean, try to find other builds, stuff that they have been successful with.
Yeah, it's similar power levels to what you're expecting to make. Exactly. Yeah, builds that they've done.
I mean, you're not going to be an LS guy and stroll into a shop that's got Ford logos everywhere, and they're like, well, we've done a couple of these, you know what I mean? When there's a nut shop right now,
Fords all the time.
Well, I mean,
I'm not 100% sure I subscribe to that, because I don't see where tuning an LS would be any different than tuning any other engine, as far as you're going to tune the engine for what it wants. So I don't see, if you walk in and there's Ford logos, why they couldn't tune a Cadillac. That part of it I don't understand.
It more. Here's you go in some and all they do is like Nissans and Hondas and stuff, and you're sitting there with domestic U.S. horsepower, and they've never touched the software, then maybe that's not the shop for you. You know, if they don't have the right software to work on your vehicle, then obviously you can't use them. You need to go to somebody who has the experience of already using that software.
Well, here is where I disagree with those statements based on doing tons of factory tuning.
Yep. It matters for the factory tunes.
Even using HP tuners, trying to tune all the big three, it is such a drastic difference in how you have to approach it. I don't
disagree with that. I'm just saying that if they don't have the software to begin with, you don't want to hand them brand new software for them to learn to tune your car.
I think you guys are saying the same thing.
That would be.
Yeah.
Yeah, that would be. Well, I mean, not really, Scott, because a lot of shops have HP tuners, right? So there again, you go to a shop where they just tune Fords, and you stroll in with your vet.
It's completely different, even with the same software with HP tuners. Yeah, HP tuners isn't the same across each platform. No, it's totally different. Even Gen 3 to Gen 4 engines from LS engines, completely different. One's torque request, one's not. You know,
I mean, really, tuning the newer stuff is knowing the tuners need to know the software and knowing the tricks for that particular vehicle. Is kind of
especially for factory tunes. Now, I tend to specialize in more aggressive aftermarket builds or whatever. And like something Mark will put together or up above or, you know, more power, those all require usually almost always, they're always doing a standalone ECU, which those are a lot more common. If you know one standalone, you probably can get your way through most of the others. But in that's where you start having to know, Mark, how to tune. And this is why Mark's confused by this question. Actually, that's where you have to start just knowing the basics of the engine to tune it, right? Regardless of what system you're using. But it's not true.
I wasn't even thinking of the factory software stuff because I never even it doesn't
compute.
it.
I know it's so many people use it, but at what year level, it's a complete waste of time. But no, and that's what you're meaning. So in theory, there is every engine wants the same thing. I have a whole lecture on that in my class, but to get there, you know, with a factory computer, especially, you're having to nudge things around just to try and get that result. You know, with a standalone, you just tell it what to do. You know, so that's why you're wondering what the deal is. But yeah, Rick is right. You if you got a guy that specializes in Mopar stuff with HP tuners, that doesn't mean he's great at small block Ford stuff with HP tuners, right? Or Mod Motor or Coyote stuff.
Well, it's like that argument or discussion they were having the other night in a private group that I'm in, and they're talking about airflow modeling. And I'm like, who the hell uses a damn mass airflow sensor anyway?
Right.
You know, it doesn't calculate in my brain.
Which part of it?
Well, my brain isn't much of a calculator, so go figure.
I think some of the other things you should look for when you go to a shop is, do they have a set of tools for the dyno? Are they a shop that has the stuff to be ready to work and solve problems on your vehicle when you go? You know, maybe you find out that you've got a bad sensor. Do they have the diagnostic tools to figure out that there is a bad sensor? Maybe it's something, if you're a carburetor guy, do they have proper jet tools to be able to change out the jets? Do they have a whole set of pin drills that they have to custom drill a jet? You know, little things like that can make the difference sometimes in who you go to. Sometimes it's not just about the dyno itself. It's about the rest of the shop parts that they have that go with the dyno.
I totally agree with Scott. I would also say, like, the operator of the dyno, are they having you do a dyno pre-checklist? Are you bringing your car to the dyno and is it on E? Okay. Is it, like we already discussed, tire pressure? You know, just a visual inspection. There's some cars that you don't want to put on your dyno. Okay. I've had engines blow up. Actually at a Good Guys car show a couple years ago. You know, you ask the guy, you know, you want me to take this 6,000 RPM or 5,000 RPM, you know, whatever they tell you to take it to, I would say drop it a little bit lower. Coolant cleanup, like when engines do go on the dyno, a lot of dyno operators will charge the customer for cleanup. So basically the overall professionalism of the person who's running the dyno and their paperwork, you know, making sure people are signing waivers, and the dyno pre-checklist, like really looking over the car for safety stuff, because, you know, drive shaft, not that you can really inspect a drive shaft, but There's a lot of things that can go wrong.
Can I add something there?
Just even something as simple as, do they check fuel pressure on the dyno? To me, that's an important thing, that they should be looking at the fuel pressure when you're doing a pull, or at least have a log of what's happening, because they're making pull after pull after pull, and your pump is getting less and getting less and getting less. And then the next day you go to drive. Now suddenly you have a pump that's not hot and it's working good again, and its pressure's back up, and they've been making all these corrections based off of weak fuel pressure, and they didn't know it was weak. Then maybe your tune is going to be way, way off at that point. So being able to look, knowing that dyno operator is looking at other things besides just your air fuel and your spark.
Yeah, that's a good point. I mean, when customers come to me, I go over their car. If it's something I haven't built, especially, you got to make sure that they've done it right. They have the right parts. You don't want a guy showing up to, I just, stroke the motor and do this blower on there. And yeah, it's still the factory pump. You're like, no, get out of here.
Well, since you guys are the dyno people, what about a customer going into a shop and knowing if the dyno's set up properly? Okay, or it's just the right one for their application. You know what I mean? I see that as a problem. Some guy wants to bring his 1,500 horsepower car in somewhere or another shop, and they have a little tiny roller inertia dyno with a thing shoved in the corner with no airflow, stuff like that. Anything a customer can look forward, going into something like that.
Yeah, I mean, I think we went over that a little bit about airflow. Look at where the dyno's positioned in their shop and ask them if they have exhaust extraction, what kind of fans. And you could bring it up lightly, and say, hey, my car likes to get hot pretty quick. You guys got good fans to keep it cool. And yeah, if you're bringing 1,000+ horsepower car to a shop, I would definitely call them first and ask them, what dyno do you have and what size is the roller? Some of the biggest stuff, I think, is even customer education on a dyno, how they work and operate.
Make sure your tires fit on the rollers too, because some cars are narrowed and they don't fit all the way on. So you got to ask what their minimum tire width is for the inside of the tire, outside of the tire. You need to know how those are spaced. I can't tell you how many times somebody's brought a car to the dyno and they've got this ultra narrow rear end and tires tucked around the housing of the rear end where there's 3 inches of space between the two tires there, and you can't put it on the dyno. It's just, sorry, half your tire hangs off of it. It's not safe for me to dyno this.
Yeah, I mean, my particular dyno that I purchased from Dynocom long before I worked for them, for my shop, is a 7500 series, right, which is a 86-inch wide roller, and it's all one piece roller. So that kind of stuff I don't have to worry about.
Is everyone still there? Or do they just get tired of talking?
I don't know. There was a...
I just had to cough up a lung again.
No problem. No, that's good stuff. So someone else asked questions, unless anyone has got more questions about dynos, or I'm looking at the chat groups here, see if anybody, well, I mean, you can always ask. We're going to stay on for a while, but the next topic people wanted to talk about was they wanted us to talk about failures we had seen on the dyno, epic failures, or probably just in general, engines, dyno, whatever. So who wants to kick that off? Who've seen some good ones? Tom, you've probably seen some good ones. Sewell?
Yeah, I've had some stuff. I had a personal issue one time happen to me. You always see the guys, the videos of somebody walking around the car, or this and that, and then stepping on the roller and hitting their head. The best thing I can tell you is if you're around the dyno, make sure you don't have any loose fitting clothes, anything weird. We had a car doing something really weird a long time ago. So I had a buddy of mine in there rolling the car. So I hop up on it. The one dyno I had at the time was a cradle with two 12-inch rollers, and I didn't realize that my shoe came untied, and grabbed my shoestring and basically pulled it in, sucked my leg in between the dyno. Happened so fast, it ripped the back of my boot, hit the ceiling, put a dent in the ceiling, scared the hell out of me. I thought my leg was done. I got lucky and just pulled myself out as quick as I could. But if you're around a dyno doing anything like that, make sure you don't have any loose fitting clothes, anything like that going on, because that stuff does happens a lot. I had a good friend of mine out in California. He'd been around dynos for, 15 years, super experienced. They were dynoing a trophy truck, and they had an issue. They stuck their head. He put his head underneath there, and I don't know the full story, but something happened, and it ended up killing him. So, these things are tools. You can get hurt. So be very, very conscious when you're around one.
We had a customer who brought us a Pro Mod that wasn't the chassis hadn't been done yet. They had just bought the car and they were converting it, and they'd already done the engine and done a few things to it. And they brought us the car to dyno, and a tire blew out on the dyno and ripped basically the entire back half of the car out. Literally ripped the whole left side of the car off when the tire went, shot it clean out into the road, across the street. I mean, it went a long, long ways. The guy came back a second time, had a full cage in there, and was buckled in, strapped in, ready to go after that. But it scared the crap out of everybody when it happened. The guy was pretty sure that he was no longer in the car from the look on his face.
I had a guy come in one time, had a big block thing, made a bunch of torque. It was real weird. In the middle of a pool, drive shaft broke. Thing come flying out 800 mile an hour, jumped over top of it. So stuff does come out and shit happens. So you have to be very, very conscious when you're around them. And a lot of times that's why people don't allow their customers around the dynos. Shit happens. And it happens really fast.
No, it was funny. Go ahead. I'm sorry. Go ahead, Allison. You probably heard way better stories.
I was just going to say, I'm sorry. That's what I was going to say. A lot of people don't let their customers drive their cars on the dyno. We've had people who've let customers drive, and I would say front wheel drive vehicles are really squirrely on dynos. And you'll have people, they'll just freak out and they'll just turn the steering wheel. You don't want that to happen.
Yikes.
Oh, and here's another thing. You want to make sure that the car is stopped before getting out of the vehicle. A lot of people will do that. It's still rolling on the chassis and then they'll get out. That's a bad idea. Make sure the car is stopped.
Find that people don't realize it's still rolling and they try to put it in park as well. Probably won't hurt anything because you just push the little locking fork out and it click, 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 But in general, not a good thing to do.
My story, let's see. We were at Alamo Auto Sports, Bryce's shop down in he's down there in Fort Worth as well. And we had a Bonneville land speed type car on there, and it was I think I was just gently rolling up at I hadn't even rolled all the way into the throttle. I was operating it on the dyno. I was driving the car, and I rolled into it half throttle at 180 miles an hour, and it literally a 7-pound chunk of tire comes off this car, goes flying straight out the back. Now it's up in the air about waist high on the dyno, up in the air, and it's literally the tire goes between two guys, one of whom was at our class a couple weeks ago there at Dynocom. Literally, two guys are standing behind the car just having a conversation outside the shop, the garage door, but behind the car, maybe 30 feet away. The chunk of tire goes right between them. Doesn't hit either one of them. Goes right between them about waist high. Yeah, go figure. Goes probably 75 or 80 yards through a wooden fence and then through into the back seat through the window of a car parked that nobody was in the parking lot. I mean, a grand total 80 or 90 or 100 yards this thing went. And just faster than the eye could catch almost. They're like, what was that? What happened? Well, in the car, it loosened up the straps. All hell broke loose. I thought for sure I broke a drive shaft. I slammed on the brakes, and this car had a set of $7,000 an end Lamb carbon brakes on it. And those work pretty interestingly. They take a second to heat up, but then they clamp down pretty quick. When everything came to a stop, it had busted a strap. And so the straps were at an angle, so the car wanted to go forward and it almost rolled off the front of the dyno. And I was staying on the brakes, and chassis guy was there, and everybody's like, stay on the brakes. After it stopped, don't move. The front tire is literally if it goes an 1/8 inch farther forward, the front of the car is just going to clunk. It's going to drop down on the chassis, and it was going to be ugly. But that happened to us. That's probably the worst thing. And that's why at my classes, I get the hell out of the way, and I tell people this too. I'm like, man, get away from the car. You do 1,500 pulls a year, at least 3 or 4 times, shit comes flying off the car. Take a look at the 1320 video of the guys in Kansas City where a charge pipe comes flying off the front of the car and thunks some guy in the head. It's funny now because he didn't get hurt, but just dumber than shit having all those guys standing around the car so close. You know what I mean? So don't be stupid. Get the hell away from the car. Let the operator handle what's going on. Stay in the car, and then everybody else get way, especially from behind the car or anywhere in the rear quarter. If you got to be around it, be up towards the front. And if it's a longitudinal engine, fine. If it's a transverse front wheel drive type of deal, then I've seen one. I saw a 4G63 chuck a rod and a piston out the front of the car, and it went flying 60 feet, and piece of rod stuck in the wall knee high in drywall. Stuff comes flying off of the cars and you never anticipate it. So I'd say get the hell out of the room is what I tell people. Just stay away. Make the pull. That's what we have data logging for. But my thoughts,
especially not behind the car.
Yeah, definitely not behind the car.
You guys actually look. Oh, sorry. I was
not so huge. Like, you got parts that come off and destroy other parts, like belts that fly off and drive shafts underneath. It'll scare the crap out of you. I mean, people eat turbos all the time because parts fly off and get sucked right in.
I was going to ask a question about tire. Yeah, tire inspection. One of the things I've come across hanging around the land speed guys, especially some of these Bonneville guys, they tend to keep those tires around for ages. And I'm not quite sure why, lack of funds. But do people routinely look at age of tires? Because old drag tires, can go away spectacularly without being all that old.
Yeah, I mean, I do anyway. My last dyno day, I did turn away one guy because his drag radials had cords showing in the middle. And I'm like, dude, no, not happening. And I went through that. I went down to another shop for dyno training, and they also had a dyno day event the second day I was there. And they loaded up the car and, they're ready to rock and roll. And I was walking around kind of doing my own inspections. And I stopped the owner of the shop and I said, do not let this car run. I mean, if it was me, I would not, but I'll make it your call. And I pointed out the tires to him. And he said, yeah, let's not run that.
So what else? So I got a half hour. Anybody else have some good fails, or let me keep going? I had
I've got a good story I'd like to tell, but it has nothing to do with the
dyno. Pile of shit story. Tell them that one you told me the other night. That was pretty good. It wasn't actually a huge pile of shit, but it was some fun stories.
Well, it's when I'm done, you'll understand why I told the story. A customer of mine a number of years ago had me freshen up the 427 in his 70 Chevelle. 427 big block. It's a bracket car. The guy's 70 years old, and he doesn't want to go quicker than 10 O's because he doesn't want to deal with all of the SFI stuff. Freshen up the motor, just basically fix what was wrong with it. We weren't trying to go any faster. And on the fourth season, it broke the crankshaft. And it was a crankshaft that was its original GM 427 crank from the 1960s. It broke between the number 3 and number 4 main web, and the number 5 and 6 rod journal just came out. It just broke. There wasn't any reason for it other than it was old. Who knows how many times it had been on the 2-step. And that was at the first race of the spring last year. So we put a new 427 together for him as quick as possible. I think he missed one event. Got him into the racetrack. I think literally on the third hit of the new engine, he broke the right axle tube right off the rear end housing. It was a factory GM 12-bolt housing still. Broke the axle tube right off. So ordered up a Mosier housing, ordered up housing ends, ordered up the ladder bar brackets, and built a new housing for him and transferred the spool and the gears and everything. Got him back to the racetrack. I think we missed one other event. Finished out the year. There's, I don't know, maybe 30 or 40 passes on brand new motor. And, everything ran well. He was happy. Season ends. He trailers the car to his house. He fires the car up, backs it out of the trailer, pulls it in his garage, and shuts it off. Takes the trailer away. About the next week, he goes out to the garage, pulls the valve covers off to back off on all the valve springs for winter storage. and he takes the plugs out and he puts a breaker bar in the motor and he goes to turn it and he gets about a half a turn and all of a sudden the motor just locks up solid and it won't turn. And he came over to my shop and says, "What do you think's wrong?" I'm like, "I don't know, but it's not a good thing when you have a brand new motor that doesn't turn." I went over to his house and put the breaker bar on it, and it literally would not turn in the clockwise direction. And I tried it counterclockwise, and it moved a bit, and I hear tink, 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 tink inside the motor. I'm like, "What was that? There's something inside the motor. That's not good." So I went back to my shop. I got my borescope, went back to his house, and we're looking around, and I was in cylinder number 4, and I'm looking, and I'm like, "What is that?" And I looked at him, and I go, "It looks like corn." And here what happened is that a mouse crawled up the header, crawled up the primary tube, and dumped corn in the cylinder past the exhaust valve. So I set him up with an adapter for the vacuum and said, "Hey, get each piston as close to top dead center as you can and vacuum out the corn and we should be okay." And so he worked on that and got it pretty good. And the motor was freed up, but there's still this spot that it gets to that's real stiff and it just doesn't feel right. And he borrowed my borescope and he found in cylinder number 1, well, the mouse is still in there. So now I'm going to try and get the mouse out through an exhaust valve before I have to pull a cylinder head. But the moral of this, I mean, none of this is really a failure other than how much trouble you can have from improper storage. And who would have thought that leaving the headers uncapped, this isn't a Formula One engine where you pull the headers off and put exhaust port plugs on it. I mean, this is just a bracket motor. It's right around 700 horse, and he's raced this car since the early 1980s. He's never had an issue. It's always been in the same garage, never had a mouse in the garage before, and yet look at all the trouble it's caused just because the headers were left uncapped. So that was Kenny Howard says, "Run it, it'll come out."
Right.
But the amount of damage, let's put it this way. Think about the amount of damage with the corn in there that he could have done had he hit the starter rather than turning over by hand.
Right.
And that could have been go ahead.
Or with the mouse, think of what damage the mouse itself could have done being in there more than the corn.
Well, yeah, it's not really a failure, but at the same time, it's a horrible amount of pain in the ass just because the headers weren't capped. So it's just every single one of you guys, or not everyone that's listening, but I would bet vast majority of you have race cars, and just think about that for a second next time you store your car. That's all I had to say.
Yeah, Mark. And the moral of the story here is just keep some pussy around to get rid of those mice.
Oh, wow. All right. Now we're all off the hook.
I was wondering, it only took her an hour and 34 minutes.
The worst I saw was we had a customer that had a Ford with an old mod motor where the intake comes off and there's the starter underneath, and they had about 400 walnuts under there from some squirrel.
Oh, we get that all the time out here where I'm at, out in the country.
Well, I mean, I've heard of acorns or corn in mufflers of cars, and you fire it up and it blows all the corn out the exhaust pipe in the spring. I've seen say like a mouse nest in a carburetor and an air filter, things like that. But this is the first time that I've ever seen a mouse that crawled up a primary tube, and there was corn in more than one cylinder. So he was a very industrious little shit.
Yeah, I have a friend of mine, Justin, with a Z06 vet, who he had just texted me and he said, "Fuck mice, bro," because he had one that he chased around that car for a week. I swear, tried pressure washing it out, all kinds of stuff. So it was quite an interesting story from him.
Well, I have a friend with a Lexus that a mouse got into the wiring harness right underneath the brake booster and the firewall, and it ate about 11 or 12 wires in the main harness, and that was a lot of fun.
Mice love the wires on those because they coat them with peanut oil when they're when they're making them, and they don't get it all off, and so they find that, and it's tasty to them.
I'd like to go back a second. Just going through some of the Facebook comments, you guys are talking about timing. They're again going to a shop with the right dyno. You can use the force that the load cell is reading to kind of see how, what the engine likes for timing, put it in a steady state mode. Obviously, with a standalone, it's way easier. Factory tuning is a little tricky. Yeah. With factory tuning, it's a little more difficult because you have to basically log it in steps, but you can read how much torque, the motor's putting out in steady state at one particular level of timing and sit there and change that. Some guys were talking about LS timing. So, interesting story. And Scott experienced some of that at the class with dropping timing in certain parts. The car picked up power.
God bless him. We had our good buddy Ken White was there with his turbo Buick, and he's one of the he's the hey
right
man. What is timing? I'll put it all the way up, And that's a lot of people think that way, or mistakenly, or don't realize it. Well, more isn't always better. I pulled out 4 degrees, and the car kept picking up power. It took me 6 degrees before it would start losing power, and so it was an interesting lesson. And I always tell people the lesson there is, when it's time to figure out what's going on with timing. Bill Fowler and I had the same thing on the engine dyno with his. Better to take it out first and make it lose power, because Bill's, we were making pulls, just sure it wanted more timing. And we were getting ready to put more in it. We're like, well, let's take some out first. And it picked up power, right? And you're like, ouch, so always start by taking some out if you think you're anywhere near, MBT.
Yeah. I had a customer that came in with a LS that was previously tuned by someone else, and he lost a motor. Got the motor rebuilt, redone, and me looking over the tune, the first thing I thought was, I'm like, wow, this thing is running a lot of timing. And so I backed it all off and went through. I had to go through all the virtual torque stuff, it's a Gen 4 GM. And sure enough, I made the truck. It was making almost 50 more horsepower when it left my shop, and the engine ran cooler. The transmission shifted correctly because all the load tables were set up correctly. It makes a difference to pay attention to that and have a tuner and operator that knows what to look at.
Scott, am I allowed to talk about the Escalade that was locked at 16 degrees?
Yeah, if you want to. Don't talk about the famous big name performance shop that built it, maybe. I don't care. Do you care? It was a Hennessy truck. Fuck it. We'll talk about it. It came from Hennessy.
Well, I have a customer that bought a brand new HPE 650 Escalade and advertised at 650 horsepower
with a warranty,
with a 3-year, 36,000 mile warranty. He had originally come to me before he ordered the truck and asked me if I'd supercharge it, and I said, "Of course I will, but why would you buy a brand new Escalade and then remove the powertrain warranty? That makes no sense. Why not drive it for a bit and then supercharge it?" Well, he looked around on the internet and he found Hennessy offered one with the warranty, so he bought it. And they lost the truck after he had the truck delivered out there. They lost it for a month or two in some back lot of some dealer and this and that. It took forever to get it. He finally gets it, gets 1,000 miles on it, and it starts burning oil. And not just a little bit. It was like a quart or two every couple hundred miles. And it was it was awful. And they said, well, we have to do a oil consumption test. He did it. Oh, you did it wrong. You have to have the dealer did it. He had the dealer do it. Oh, they did it wrong. We need it this way. Basically, they just kept putting it off. And then they just quit taking phone calls and said, well, it's GM's issue because we never did anything with the engine itself. We just put the supercharger on, and this is GM's problem because it's consuming oil.
Oh, wow. That's passing off the buck.
Yeah, well, GM said, well, we didn't supercharge it. It's not our fault, which I kind of agree with GM there. Anyway, he had me build a fresh motor for him, and I did a lot of the changes to it that would make it like an LT4 instead of LT1. And we put it back together, and we got it on a Mustang load-bearing dyno. And the first thing that we found was that the timing was locked at 16 degrees and that the knock sensors were set so that they could only pull 0.3 degrees of timing. I think that was the minimum you could do. And it would put the timing back in.
That was the maximum it would let pull. It basically wasn't letting them pull any timing.
Right. 0.3 degrees is all it would allow. You couldn't, I don't think you could set it any less than that. You couldn't set it to 0 degrees. It was like 0.3.
Let's just say they disabled the knock sensors. How about that?
Absolutely disabled them.
Right.
And, I forgot to say when I pulled the motor apart, I had 8 pistons that were broken in between the top and the second ring. All 8 pistons were broken. And the customer had audible detonation every time the transmission would shift, and it would shift to the next gear. It would go into audible detonation. When we were done tuning it, I had lowered the compression ratio like a point and a half, and it's still the most that it liked for timing was 13 degrees, maybe 14 degrees. I forget the exact, but it was 13 or 14 degrees was as much timing as it liked, with a 1.5 compression lower, a camshaft with more overlap, which should take away low speed cylinder pressure. And it's still only like, and it's still like 3 degrees less timing. So to take a timing number and say this is the timing number that all LS engines or all LT engines or whatever like, and just plug that in and not pay attention to it, they ended up with 8 broken piston rings because of it. And that is completely careless in my opinion.
I'm sure we've all had to fix those tunes where people have just copied and pasted something in that's, it's an LS, it takes 28 degrees. And, it definitely doesn't all take 28 degrees. And we've all probably had to go through a bunch of that crap.
Oh, yes. The logs and tunes we could share.
Oh, good Lord. That's where they have the Bullsack Base Maps Facebook group. Join that if you want to see some funny stuff, man. They're calling each other out, too. It's hilarious.
Oh, wow.
So,
Scott, we almost got there on this question, but it seemed like it came up a step short, which is the value of step RPM tuning versus just always tuning, because a lot of these cars are not just all-out drag cars, but true street cars, drag week cars. All these guys usually where I think they're using HP tuners or something, are looking for something that they can, like the Escalade or whatever, to actually drive. Do you or any of the other guys here want to talk to this value of doing step tuning and other stuff to figure out
I'll talk
best timing and some of the other values?
Especially with manual transmission cars, it works a little better than converter cars. But if you look at a fuel table and a spark table, you really want to try and get to hold the engine or the powertrain in all of those different cells, or as many of them as you can cover, not just wide open and idle. Idle's the bottom left corner, wide open is the strip across the top. You really want to try and spend as much time on all those cells as you can. Easier on a manual trans car, obviously, but I'll do different steps. And again, this is why an eddy current dyno, like what they do at Dynocom, is very important, because the eddy current dyno, you can say, hey, hold my wheel mile per hour at, say, 40 miles per hour. No matter what power input, fight it to where it's holding the 40 miles per hour, right? And then I can, as the operator or the dyno or driving the car, roll in the throttle and out. And no matter what, it's just going to be like going up a steep hill. It's going to grunt and everything, but it's not going to wind up RPM or speed. And that lets me test and monitor torque at that particular wheel speed or in roughly that same engine RPM. The more power you put into it, the more torque you apply, the more the converter's going to slip on a converter car. But similar deal. You want to work all those areas of the map and make sure that your fuels are right, and then try and, approach mean best torque or maximum brake torque or whatever you like to call the MBT terminology. There's like 17 different things people call that acronym. But so really it's just steady state tuning is what I call it. But I like to do that. So.
Yeah, I think steady state tuning ends up evolving into the customers that say their car drives really great.
So much
the drivability.
Better. Oh, when you do the steady state tuning, the car runs so much better when you take it out on the street and it's faster.
if you got a car that bucks a bunch, that steady state tuning can help you figure out what it wants to get rid of that buck.
Yes.
Often it's timing or fuel. Sometimes it's a combination of both, but you can sit there and you can tell it, oh, I'm bucking at 2,500 RPMs. Great. Put it there, tell it that speed, make it buck, and then you can just push the timing around. Oh, look, it cleaned up. Oh, maybe it wants less there. Maybe it wants more there. You can play with the fuel a little bit. It wants to be a little leaner, wants to be a little richer. You can find that thing. And the dyno will just hold it there all day long for you. I mean, obviously don't do it to a point where you're 3/4 throttle all the time and you're putting a whole lot of heat into the engine because you're just holding it there and it doesn't have anywhere to go. But, take breaks, let it cool back down a little bit, go right back at it. You can keep going right at that same RPM until you find what you need.
The Pizzeria cam, if anyone's on Facebook, is awesome.
Did you catch that? Every time I take a drink of the Pizzeria, I'm flipping the Pizzeria camera. I got in-studio camera capabilities now.
And to touch on what Scott Evans was saying, if anyone has ever taken Scott Clark's advanced class, he goes into great detail on steady state tuning, which is very, very informative and interesting.
Tough to do those classes, guys. I would love to do more. People ask about them. That the problem is it's expensive. We bring an engine on an engine dyno. We do individual O2 tuning, individual EGTs. We'll spray it with nitrous. We've hit a stock 5.3 with a cam upgrade. It has a Bewley donated us a cam and springs and retainers kit, but we've hit it with 600 shot of nitrous, and people tell us that can't be done. I was just on the Nitrous Tech forum, and all these guys, hey, you can't do that. Sorry, that won't work. Blah, blah, blah. Sorry. Done it a lot of times. If you know what you're doing, it works. But the advanced classes are so much fun. I like getting into that stuff. It's just really hard to put them on. I think we may try and do some in some centralized cities, like maybe something in Houston or Fort Worth, or maybe something in Chicago. But look for that probably this winter. We'll do some more advanced classes like that.
Yeah, I would think you'd be able to fill up a DFW class on that. I would think.
I need an engine dyno. You guys need to get us a prototype engine dyno down there ready to go. I've got the engine and everything. We use Brad Nagel's LS. But as if you don't have enough going on already. I feel bad asking.
I know.
But
they need more.
Allison's promising an engine dyno. You didn't even get to check out the injector machine. That's too bad.
No, I didn't stick around to check that thing out. When I heard the price tag and what it was for, I'm like, that's like for guys that sell 1 billion injectors or whatever. But yeah, I get it.
Hey, Scott, if I can throw out one more question. About every third day when I'm following various threads on the internet, somebody will sooner or later say something to the effect of, well, all this chassis dyno stuff is nice, but you really don't know anything about how the car is going to work until you take it to the track. So you might as well just do all of your tuning at the track and save the money.
That's ridiculous, if you ask me.
It's
Anybody care to comment on this and help? I
will.
I think it's one of the biggest myths out there.
You're not going to put a pro mod. You're not going to put a 4,500 horsepower pro mod. Well, you may put it on the hub dynos, but up to this point, you weren't going to put it on a chassis wheel dyno. And a lot of those guys, I'll take them straight to the track. I mean, I just took a guy. The Holly guys tend to come my way for the remote tuning, and I just did a 700-inch all billet motor. Was it a Musi combo? I think it was a Musi motor with 4 stages of nitrous. We never took it to a dyno. We never put it on an engine dyno or nothing. Just took it straight to the track and ran it. Sometimes you have to, but I'd say 98% of the time, better to take it to the dyno and optimize it there first, because the dyno is not just for performance measuring. It's your opportunity to shake everything down in a situation where you can watch if the car's dropping fluids at wide open throttle and things like that. So, I mean, yeah, definitely go to the chassis dyno if you can.
We took a pro mod with a 700-inch motor that the guy stuffed in it. Sorry, 810-inch motor that the guy stuffed in it. And we put it on the dyno. We weren't able to make long, full pulls because it just makes too much power. You just can't keep it down. But we were able to get a starting point before we went to the track with them and make sure, exactly that. Hey, is this thing dropping fluids? Is this pump going to keep up? Is this, or is everything mechanically sane before we go try to drive down the track and maybe scatter it everywhere on a track day? We don't want to do that.
No, I mean, it makes sense. You get an opportunity to at least get a few, like 1 or 2 seconds of a pull at wide open throttle, right? I mean, that helps.
Yeah, it gives you a starting point. It's something.
Yeah. At my class in Carrier, Mississippi, we had a guy. Well, it was one of Scott Taylor's cars. Freddie Sandrock had put a motor in it, and we were shaking down the engine, and he knew it was going to have problems. He's like, "I want to run this wide open and see what's going to break." And we did. We had issues. We pushed out a head gasket, and it had the wrong studs. I think Tom Viggy was telling him what was wrong with it and why it was going to break. Actually, when he figured out the parts, Tom told him what was going to break and when, and it did right on the money. And it was kind of cool, actually. And Freddie's like, I knew it. That was good. And he came back with the thing all sorted out, and we cranked it up, and he was making passes. In fact, he just had a brush with the wall at one of the Dirty South No Prep events here last weekend. He's fine. I posted a picture up on the thing. It just scraped the wall a little bit. They'll straighten it out. He said he'll be back in a couple of weeks. But yeah, anyway, so it was you can do a big fast pro mod on there, and we were just doing short hits at wide open throttle, just maybe 1-2 second pull. Not a full pass, but enough to get the engine to get some load on it.
Yeah, and pretty much any car you can take to the dyno to get you in the ballpark. Yes, you still need to fine tune it at the track, but why waste all day at the track trying to find a number when you can get it close enough to start and have it where it needs to be in a couple passes?
Agreed. I like going to the dyno for that. I'd if I have a choice, I say let's go to the dyno first, but sometimes we don't have a choice.
So the other internet story that goes along with that one is that the dyno is harder on engines and cars than the track is.
Well, there's stipulations to that.
Yeah.
Because yes, like a pro mod car that runs X amount of few seconds in the quarter mile, you could stick it on a set of tripods and hold it to be a runtime longer than what the car would actually do at the track. So then, yes, it's harder on the motor.
It is because you're building at that point in time. You're building more heat in the chamber. You know, you got a whole bunch of issues. If you're going to make a 14-second pull on a car that runs high fives or mid fives in the quarter, And the other thing I noticed, you got to be careful. I saw a certain competing brand hub dyno on at the 3,000 plus horsepower level. What I did not like is that it forced them to start at a low RPM. What I liked about Dynocom is like just take it up to whatever RPM you're going to run and roll into it. It'll measure. They'll record the whole thing. But this guy, they had to start the pull, lugging the motor way down and hold it there for a second, and then it would let it sweep. And it just seemed like, I'm like, man, you're really abusing that engine. That it's the kind of abuse it's not seeing because they were lugging it so much harder than they would at the actual track. At the track, the thing will get up to an RPM range. It's comfortable, 8,000 to 9,500 RPM and run fine down the track there. But you start this thing off at 5,200 RPM and go wide open throttle and start building boost. And, that's starting to get hard on parts. And you really better have your tune in check if you're going to run it somewhere that it doesn't see the similar load in RPM going down the track.
That really comes down to having a dyno operator that knows what he's doing.
Yeah.
I mean, I think the dyno operator
can do it. I mean, some of these
Exactly.
dynos don't let you do it any other way. It's kind of interesting.
There's also the speed factor. You're not getting 150 miles an hour worth of air out of a little fan in a shop in front of your car. So
yeah,
you run more chance of overheating things on the dyno because you don't have the same airflow pushing across the radiator during that pull.
Yes, that's why a lot of guys that come down to Dynocom, they'll ask those questions about what the eddy brake can hold, and we go through the charts and show them, okay, after X amount of time, the eddy brake is too hot. You're only going to be able to hold back this much. But the hindsight of that is, I'm like, look, guys, most of the time, the car is going to have to take a break before the eddy brake. You know what I mean? It's going to be too hot. Concur?
Yeah, of course.
I mean, because a lot of shops are just not going to have the fans, and there again, I mean, most your say average street cars, even guys that are coming up on 1,000 horsepower, you're still going to do an 8 to 10 second power pull sweep, and that's enough. You know what I mean? That's going to be quicker than what the car is going to do on the road, so it's not harder on the engine. You know what I mean?
Right.
There's no reason to do a 45-second pull in fourth or fifth gear. All you're going to do is hurt parts.
Yeah, exactly. I mean, if you don't have the airflow, you better not try it. I mean, we have the whole vehicle simulation mode testing in the Dynocom software in Quantum, and you can simulate that and do really long pulls. I've done a couple of them, and it was basically to do a tune check of like, okay, if this guy, Little Mexico is famous for the high speed runs. So it's like, okay, if this guy is at a high rate of speed for a long time in fourth or fifth gear, is this car going to start knocking? Is it still going to be okay at load for that amount of time? So you can use it to check, but I don't think it's necessary to tune on that. You know what I mean?
Oh, I hear you. That's where using your judgment and having an operator that uses his judgment comes in, right?
Right.
Hey, Scott.
Yeah, brakes on cars will take a beating if you have somebody who doesn't have a proper brake on the dyno and they're trying to stop it with their foot. Your brakes will take a beating.
Yeah. Hey, Dan Parker, go ahead, man. What did you have to say?
Several times in the conversation, we've talked about motors overheating on the chassis dynos. And one thing come to my mind is having a remote reservoir with just a set of quick couplings, that you could put inline between your top and bottom radiator hose and actually use a remote cooling system for a chassis dyno, especially a motor that you're going to spend a lot of times doing like the steady state tuning, etc. And you might overheat the motor. Have a remote reservoir instead of relying on air to cool the motor. Just have a remote water tank.
It doesn't seem like a bad idea, and the Bonneville guys will run the car that way with a 70-gallon tank or whatever. But then the next problem you run into is transmission cooling and gear oil tuning and everything else that gets hot on there from not being moving. So you end up you're fighting the cooling everything. I mean, a lot of cases it's better just to get air moving over it as much as possible.
I mean, sometimes I'll have the big air mover fans. I'll put them underneath the car. I've got an above ground setup, so put them underneath the car to just try to blow on everything, headers, transmission, just help, get some airflow.
Mm-hmm.
Allison, Kenny Howard's about ready to pee in his pants, wondering where his toys are.
Yeah, you got people like, "Where's my dyno?"
Oh no.
They're working on it. Chill out. There's a lot that goes into building and calibrating one of those things and making sure it's right before it goes out the door. I learned this.
You'll receive it in 47,000 baggies with an IKEA style assembly chart.
Yeah.
And a 5mm Allen wrench.
Yeah, I mean, I can tell you between the two shows, I think PRI this last year was the best show Dynocom has had. And between those two shows, it definitely put us behind big time. We sold a lot more dynos than we were expecting. So that's been a major catch-up process.
That's totally not true.
Oh, my.
I was going to say, you guys have done a really good job with your reputation over the past couple of years and the quality of the product that you guys have. Because I remember I seen you guys years ago, and I was like, and now like you guys are up there, one of the best manufacturers out there.
By far the least bitching of shop owners about your tech support right now.
That was definitely since I came aboard. Yes.
I didn't see that coming.
That's why I hired Rick.
Yeah.
I tried to quit several times.
No. I know it's good to hear, good thing to hear, because people are like, I'm getting really good tech support. They answer the questions. What about the quantum software? So a lot of people talk about quantum and said, man, what a killer update this was. What was the deal there? What was the big change there other than a really nice user interface?
And I would like to say, anybody listening to the podcast, if they need a quantum update, like Jared Harlow or Kenny Howard, Jarrett, any of those guys, they need quantum. They mention this podcast, we'll give them a discount. Also a new dyno purchases. Yeah, just mention this podcast. Call me, we'll get you a discount.
Mention this podcast, we'll mark it up and then give you a discount.
Exactly. The quantum software, really, we were the first dyno company to come out, believe it or not, with an actual Windows-based software program, which is kind of going way back there. But we were the first, and then the next one right behind us to follow was actually DynoJet. Everything prior to our original software program was DOS-based.
Wow.
So that's just...
And that's back to the early 2000s, even when Windows was still widely popular. Everybody was kind of behind the times. Yep.
Well, that was probably back when you were partnered with DTS, because that's all DOS-based.
That's correct. That is correct. So we know that, and we know that in the automotive industry, not everybody knows how to navigate to a Windows directory or not. I mean, some guys are really good with computers and some guys are not. But I think what we did with Quantum Software is, and honestly, I take a lot of the calls, and if you have to go through 6 steps just to get to one thing, I think we made it a little bit more, well, we definitely made it more user-friendly, more intuitive, more app-looking. So so this button is HD, which stands for heavy duty. So if you're a diesel guy and you want to do, low hold on start type of thing where you just spool up a turbo at low RPM, there was like a button basically that explains to you, I just click this button and then this is what I should get. So we tried to simplify it, but not undersimplify it. So it's as complicated as you want to be. But I think it's a whole lot more user intuitive. And that's really based on the feedback from our customers that we've built over the past 10 years. So.
Nice.
Yeah. I mean, when I was shopping for a new dyno, I think that was probably the biggest thing that impressed me was the software.
The user interface. Wow, this
looks,
it's head and shoulders above everyone else
really
by a
good.
mile,
Yeah.
by 10 miles. Yeah.
Yeah, I see some other, graphs being posted and like dyno runs and people recording the screen. And I'm like, what the fuck are they on? A Game Boy dyno? What is this software?
Right. highly recommend, though, taking the class at Dynocom for dyno operators, and man, maybe retaking it, just because if I've noticed one thing, that's what people could really use the education, because Rick on the Dynocom, the way he was explaining what's going on, he's like, okay, well, look, your peak was more here, but here's the reason why. You stayed in the throttle a little bit longer. Your actual average numbers across, let's take an RPM range that's usable for the car, and let's look at your average numbers. And then you could see these subtle timing changes I was making so much more easily. And it brought up the repeatability and usability. And I just thought, and he was explaining why, and I'm just like, man, I wish all the operators were this well educated. So hopefully we see that. Hopefully that, people start getting a little more educated on the system. But
yeah, and then anybody that in the DFW area that needs a tune can come see me, and they know that I know what I'm doing.
Right on, brother. You tell them.
I mean, just have to be real about it. It is important because, like I explained to you that day too, Scott. I'm like, look, man, I would rather tune and lose 10 horsepower on peak, but pick up 20 through the average.
Yeah, exactly.
And there's not a lot of dyno companies that even
not a lot of tuners even understand that concept. And I didn't get it until I did spend a lot of time at Engine Masters Challenge, where it's an average game, and it's like, oh wait, so this engine's not peak. You realize at that point that peak numbers are only good if you race irrigation pumps or generators. You know what I mean? Seriously, right. It's the peak number means almost crap. It's the average through whatever RPM range. Now a lot of times converters will keep it to where you've got 1,000 RPM range or less usable range, and that lets you focus on that. But you got to understand as the operator and the tuner what range that engine's going to see, and you got to maximize that range. And that's what Rick was helping us do on these cars on this last dyno. And it was cool, man. And the cars, we took them off the dyno, and everybody reported that they drove awesome. You guys went out and started winning races right away. So it was just neat to see that we had them nailed down.
Yeah, and there was I can't remember the guy's name. The truck. I mean, we did a couple holes in a row.
Amen, brother. Shout out to Robert for bringing that truck.
Yeah.
Now his problem is power management at the hit, not our problem, right?
I mean, I'm not going to lie. It scared me a little bit looking back to the back window and seeing those giant slicks. But that truck was able to lay down. How many runs did we do where it was within 2 horsepower, and we're talking over 1,000 horse?
Oh yeah. We were making with 38, 39 PSI. And the reason it was, it was repeating within like 2 horsepower over and over, because we were having boost control issues where it was just running the big number every time. And yeah, it was printing some huge numbers. He probably doesn't want us talking about it. It was a lot more than 1,000, but it was, that truck is, now he's happy to have chassis setup issues now and not worried about the power he's making,
right.
But everybody was like, you can't make 38, 39 pounds on stock stuff, blah, blah, blah. Yeah, we can. And you know what you're doing, and you can do it for a couple. He'll make that motor will live a couple hundred passes, which is fine with him. But
right.
So, hey, we better wrap it up, man. We're over time. Not that it really matters. We don't actually have a deadline, but I tell people we wrap it up at 10. But huge thanks to you guys, Allison and Rick, for sticking it out and talking to us and explaining all this stuff. This will be a good episode. Just coincidentally, it was one of our largest live listened episodes tonight. I sit here and track the numbers, and we had a solid 145, 155 people on the entire time. So thanks all you guys for listening and sharing this stuff. Yeah.
Yeah, for sure. Thanks to everybody listening, and thanks for having us, you guys.
Yeah. Well, I always tell people this who are interested in fun. I'll give you guys the chat information, and I'll add you to our little secret group. And also, you can stick around here for a minute as I wrap it up. In fact, I'll get the outro started here shortly. But stick around, and you guys can be on the chat with us, and you can sit on any other time, any other show that you want to. So that'll help a ton. All right. Well, all right. I'll mute you guys, and we'll just stay on the way out here. We'll play everybody a little bit of commercial and some tunes, and kind of listen up, talk about the class schedule. We've added a date or two, and so we'll be talking to you guys pretty soon. Thanks. Are you interested in learning how to tune electronic fuel injection live in person with the guys from RealTuners? We have 2-day courses in dyno shops across the country. Register for all of these at RealTuners.com. Click on RealTuners Live Classes. If you'd like to bring 2 or more people, talk to us about group discounts. For more info or to make a reservation, go to RealTuners.com or message us at RealTuners LLC on Facebook. Learn how to tune your own standalone EFI systems like Holley, FuelTech, Megasquirt, Fast, and others on the chassis dyno. Includes topics such as traction control, individual cylinder tuning on a budget, and power adders. Upcoming classes with available seats are as follows. EFI Essentials in Detroit, Michigan, May 12th through 13th. And May 26th and 27th in Milwaukee, Wisconsin. Then Holley EFI Essentials at 417 Motorsports in Springfield, Missouri, June 9th and 10th. And an Essentials class covering all standalones at Nano Nitrous in Kansas City on July 21st and 22nd. These classes are designed to help you get your project running successfully in a course taught by people who've actually done this kind of stuff for a living.